Hi friends, welcome to JMK Tutorials. In this video, we are going to see about the image formation model. Okay. So first of all, what is meant by image? Image is a two-dimensional function where it can be represented as f of x comma y. Image is a two-dimensional function where it can be represented as f of x comma y. So it consisting of some value at the time. That value may be anything. F of x comma y is having some value. That value is generally called as value. So that is nothing but f of x comma y. The value or amplitude of the f at any pair of spatial coordinates. That means if you are taking a two-dimensional function, f is nothing but f of x comma y, where x comma y is nothing but two spatial coordinates. X is nothing but x-axis direction, y is nothing but another direction. That means if any function having a two coordinates, that is generally called as a two-dimensional, right? So from that, image is a two-dimensional function. So that is the basic meaning. Okay. Therefore, f is a two-dimensional function. Every function having some value, whether it may be small or having a maximum value or any value, any function having some value. That value may be amplitude, or we can also call it a grayscale, intensity. These are all the some of the terminology for representing the intensity corresponding value of a function at the corresponding coordinates is nothing but x comma y. Okay, at x comma y, the coordinates of x comma y, the value can be represented as maybe intensity or maybe grayscale value, or it may be pixel value. These are all the another names for the corresponding representation. Okay, so that means x comma is a positive scalar quantity whose physical value is determined by the source of the image. That means the value of the corresponding intensity can be determined by the source of the image only. As well as the intensity of image is directly proportional to energy radiated by the physical source. That means the value of intensity is also depends on the directly the amount of energy is radiated by the physical source. That means whatever the light is incident on the corresponding object, that is reflected back, right? That complete reflection maybe value can be depends on the corresponding source of the light only. So that means the source of the light is also proportional to the corresponding intensity value, or else intensity is directly proportional to the source of the light or maybe any waves. So here let it be considered f of x comma y must be a non-zero and finite value. So this function value must be some non-zero value, and moreover it is also some finite value. Then only we can define it as a digital image is also nothing but a some finite value. If it is a infinite, we cannot exactly determine the what is the value of that function at that pair of the coordinates. So that's why it must be some finite values. So as well as it is also must satisfy the sum of the properties, that is nothing but let us see here. First point is nothing but also the f of x comma y must be some finite value, right? This is nothing but this is also must be, that means this function value, the limits value may be existing from 0 to infinity only. Okay, now 0 to infinity. So in between these 0 to infinity, the f of x comma y value must be present, otherwise it is a infinite value. So that's why it must be a finite value. As well as the f of x comma y may be characterized with the two components. That means the f of x comma y function can be characterized with the two components. That is nothing but first one is nothing but the amount of source illumination incident on the scene. That means whatever the object we are going to focusing, so amount of light, amount of source illumination is present on the corresponding scene, and second is also depends on the amount of illumination reflected from the objects of the scene. So ఇక్కడ ఏంటంటే మనం ఆబ్జెక్ట్ మీద ఎంత లైట్ పడుతుంది, సెకండ్ థింగ్ ఏంటంటే ఎంత లైట్ రిఫ్లెక్షన్ వస్తుంది. బేస్డ్ ఆన్ దీస్ టూ పారామీటర్స్ we can define the corresponding image. Okay, these are called illumination, and second one is nothing but reflectance components. and it can be denoted as I of x comma y is nothing but illumination component. R of x comma y is generally called as a reflection component. Based on this, we can represent f of x comma y is equal to f of x comma y is equal to, it is a product of illumination component as well as reflection component, right? It is a product of illumination component as well as reflection component. So it is a product of illumination component and a reflection component. Moreover, the corresponding illumination component is also within the range of this one. That is nothing but 0 less than I of x comma y less than. That means the corresponding I of x comma y also must be some finite value. Moreover, the R of x comma y is also in the range of 0 to 1. So that means the range of this one is 0 to 1. Second thing is nothing but the reflectance component is bounded between the two components, that is nothing but 0 and second one is nothing but 1. So what represents 0 and what represents 1? That is another question mark in your mind, right? That is here the value of f of x comma y is determined by the illumination source and R of x comma y is determined by the characteristics of the image components. So that is the important. As well as let us consider the intensity of monochrome image at any pair of coordinates is nothing but at x comma y naught. The value of the intensity can be represented as L comma x of x. L is equal to f of x naught comma y naught. As well as the L can be represented as L minimum less than or equal to L max. That means where L max is the highest value and L minimum is the least value. What represents L min is equal to L minimum value is equal to the I minimum into R minimum. I minimum means nothing but minimum of the illumination component and minimum of the reflectance component, as well as maximum of the L max is equal to I max into R max. I max is nothing but a maximum component of the illumination component as well as maximum component of the reflectant component. Basically, these are the some of the typical indoor values for the corresponding illumination and components in the indoor values. Moreover, let us see here the interval L minimum is called generally called as grayscale values. Okay, the range is generally called as a grayscale value. The intensity, the interval between the corresponding L minimum and the L max is generally called as a grayscale. L min is called as a grayscale. We can also call it intensity. In practice, it can be represented as 0 less than L minus 1. L minus 1 is the maximum value of the corresponding intensity and 0 is the minimum value. Generally, L is equal to 0 represents a black value and L is equal to L minus 1 represents the white and the grayscale image. The all intermediate values are represents the shades of the grayscale, gray values. That's why it is called as a grayscale image. That is the basic meaning why we are getting it is a grayscale image. Means that the in between the black and white there is some shades of gray colors are present. So that's why it is called as a grayscale image. Okay, as well as all intermediate values are maybe shades of the grayscale, so that may be existing in the range of R is equal to 0.01 for black representation. That means these are the some of the reflection components. Okay, these are all the some of the reflectance components of the corresponding image, where R of x comma y is equal to 0.01 for black image and 0.65 for stainless steel and 0.80 for flat white wall and 0.90 for silver plated metal and 0.93 for snow. Basically, if you are thinking very clearly, generally the white color cannot absorb the maximum light, so obviously it may be reflected very easily. So that's why stainless steel, and these are all the flat white wall and silver color and snow. This is also having a maximum reflection coefficient. That means it reflected the corresponding component, whatever it gets from the corresponding source image or source light. Okay, I hope this is very clear. So finally just I will explain in Telugu in a very few minutes. Okay, basic ga mana image formation model ela form avutundi. Okay na. So basically ఈ ఇమేజ్ ఫార్మేషన్ మోడల్ అంటే జస్ట్ ఇమేజ్ ఫామ్ అవ్వాలి అంటే బేసిక్ గా ఇమేజ్ ఈజ్ నథింగ్ బట్ ఎఫ్ ఆఫ్ ఎక్స్ కామా వై అనేది ఒక 2 డైమెన్షనల్ ఫంక్షన్ అజంప్షన్ తీసుకుంటే ఎక్స్ కామా వై పెయిర్ ఆఫ్ కోఆర్డినేట్స్ దగ్గర దానికి ఒక వాల్యూ ఉంటుంది. దట్ వాల్యూ ఈజ్ జనరల్లీ కాల్డ్ as ఆంప్లిట్యూడ్ ఆర్ ఎల్స్ వీ కెన్ ఆల్సో కాల్డ్ as ఇంటెన్సిటీ అని పిలుస్తాం. ఈ ఎఫ్ ఆఫ్ ఎక్స్ కామా వై వాల్యూ మస్ట్ బి సమ్ ఫైనైట్ వాల్యూ అయి ఉండాలి. అది 0 నుంచి ఇన్ఫైనైట్ కి మిడిల్ లోనే ఎగ్జిస్ట్ అయి ఉండాలి. ఈ ఎఫ్ ఆఫ్ ఎక్స్ కామా వై ని 2 పారామీటర్స్ క్యారెక్టరైజ్ చేస్తాయి. అంటే ఈ 2 పారామీటర్స్ ని బేస్ చేసుకుని ఎఫ్ ఆఫ్ ఎక్స్ కామా మనం డిఫైన్ చేయొచ్చు, లేదా అనాలిసిస్ చేయొచ్చు, లేదా క్యారెక్టరైజ్ చేయొచ్చు. ఆ 2 కాంపోనెంట్స్ ఏంటంటే వన్ ఈజ్ నథింగ్ బట్ సోర్స్ ఎలిమినేషన్ అండ్ సెకండ్ వన్ ఈజ్ నథింగ్ బట్ రిఫ్లెక్టెన్స్ కాంపోనెంట్. సో సోర్స్ ఎలిమినేషన్ మీన్స్ అంటే మనం ఎంత లైట్ అనేది ఒక ఆబ్జెక్ట్ మీద పడుతుంది, ది అమౌంట్ ఆఫ్ సోర్స్ ఎలిమినేషన్ ఇన్సిడెంట్ ఆన్ ది సీన్, మనం చూస్తున్న ఆబ్జెక్ట్ మీద ఎంత, దట్ ఈస్ నథింగ్ బట్ సోర్స్ ఎలిమినేషన్. ది అమౌంట్ ఆఫ్ ఎలిమినేషన్ రిఫ్లెక్టెడ్ బై ది ఆబ్జెక్ట్స్ ఇన్ ద సీన్, ఎంత పడుతుంది, ఎంత రిఫ్లెక్షన్ అవుతుంది. ఆ ఎలిమినేషన్ అంటే ఒకటి, దిస్ ఇస్ ఎలిమినేషన్ ఈస్ నథింగ్ బట్ అమౌంట్ ఆఫ్ లైట్ ఈస్ ఇన్సిడెంట్ ఆన్ ది సీన్. రిఫ్లెక్షన్ మీన్స్ దట్ అమౌంట్ ఆఫ్ లైట్ ఈస్ బ్యాక్ ఫ్రమ్ ది కోరస్పాండింగ్ ఆబ్జెక్ట్. అంటే ఎంత, దాన్ని మనం ఇల్యూమినేషన్ కాంపోనెంట్ అండ్ రిఫ్లెక్షన్ కాంపోనెంట్ 2 పేర్లుగా పిలుస్తాం. ఈ ఎఫ్ ఆఫ్ ఎక్స్ కామా వై ని ఎలా రాస్తాం ఇన్ టర్మ్స్ ఆఫ్ ఇల్యూమినేషన్ లో, ఎఫ్ ఆఫ్ ఎక్స్ కామా వై వాల్యూ ఈజ్ ఈక్వల్ టు ఎఫ్ ఆఫ్ ఐ ఈజ్ ఈక్వల్ టు ఐ ఆఫ్ ఎక్స్ కామా వై ఇంటూ ఆర్ ఆఫ్ ఎక్స్ కామా వై. Again, this elimination component is also some finite value compulsory, that is nothing but 0 less than I of x comma y less than infinity. At the same time, second component is 0 less than R of x comma y is less than or equal to 1 అయి ఉండాలి. So these are all the some of the things. మరి ఇక్కడ ఆర్ బౌండరీస్ ఉన్నాం కదా, మరి రిఫ్లెక్షన్ కాంపోనెంట్ వచ్చేసి 0 ఉందంటే టోటల్ అబ్జార్ప్షన్ ని, ఆర్ ఈజ్ ఈక్వల్ 1 ఉందంటే ఇట్ ఈస్ అ టోటల్ రిఫ్లెక్షన్. దట్ ఈస్ ద మీనింగ్ వై ఇట్ కెన్ బి రిప్రజెంట్ ఆర్ ఆఫ్ ఎక్స్ కమ్. సో బేసిక్ గా వీటిల్లో మెన్షన్ చేస్తాం మనం ఇల్యూమినేషన్, ది నేచర్ ఆఫ్ ఐ ఆఫ్ ఎక్స్ కమ్ డిటర్మైన్ ది ఇల్యూమినేషన్ సోర్స్. కాబట్టి వీటిలో ఇంటెన్సిటీ వాల్యూని మనం బేసిక్ గా L తో రిప్రజెంట్ చేస్తాం, వేర్ స్మాల్ l ఈజ్ ఈక్వల్ టు ఇంటెన్సిటీ వాల్యూ, L మినిమం ఈజ్ నథింగ్ బట్ మినిమం ఇంటెన్సిటీ వాల్యూ, అండ్ L maximum ఈజ్ ఈక్వల్ టు maximum intensity value. సో L minimum ఈజ్ ఈక్వల్ టు అగైన్ రిప్రజెంటెడ్ ఇన్ టర్మ్స్ ఆఫ్ ది ఇల్యూమినేషన్ లో రిఫ్లెక్టెన్స్ కాంపోనెంట్ రాస్తే మనం I minimum ఇంటూ R minimum రాయొచ్చు. సో బేసిక్ గా జనరల్ గా మనం రాసేటప్పుడు 0 to L minus 1 అని రాస్తాం. ఓకే, ఇట్ స్టార్ట్స్ ఫ్రమ్ 0 కాబట్టి, అదర్వైజ్ ఇట్ కెన్ బి రిప్రజెంట్ 1 to L అన్న రాయాలి. సో ఇట్ స్టార్ట్స్ ఫ్రమ్ 0 to కాబట్టి 0 to L minus, where 0 represents a black color and L minus 1 represents a white color. So that is nothing but just a brief introduction about the how image form.